So, welcome to the latest NeoNephos community call on the 10th of September, and I'm happy to be your host today. So, my name is Christian Neu. I'm from SAP. I'm also the governing chair of the foundation, and today we wanted to give you like a current overview about where we stand, what was the development so far, and maybe I also have in the agenda. And also, please have in mind the antitrust policy notice from Linux Foundation. And for that, I would continue with the agenda. So, yeah, basically, I would like to give you a short overview about what's the latest development over NeoNephos Foundation and how you could get involved. What is currently planned, or what are we currently up to? And then I would hand over to my colleague Mirza, who gives a demonstration about Platform Mesh, one of our projects from NeoNephos Foundation. Really interesting. And afterwards, we can have a Q&A, and you could also let me know if this is the right format, if you would wish for something else, if you could prepare something, should prepare something for the future to get you guys involved in the foundation, and happy to also have like one-on-one conversations about joining the foundation, and or doesn't need to be joining, but also how can we get your feedback and contributions to the foundation. Okay, so let's get started. NeoNephos Foundation, I'm not sure how many people are new in the round, but basically the foundation is part of the Linux Foundation Europe, and we try to aim to create a cloud edge continuum for Europe. What does it mean? This is about digital sovereignty. How did it came up? So basically, SAP is part, as other companies, of the IPSAI CIS development. IPSAI CIS stands for Important Project of European Common Interest for next generation cloud infrastructure and services. Our idea was like, it doesn't make sense to just publish software if nobody uses it. And also, you want to have these contributions to work together to define it as a de facto standard. And that's what we are currently working on, to bring in an open source reference architecture blueprint for cloud infrastructure and services based on de facto standards. We are working on a very much agile mode. We are trying to get the community involved as possible, as we think it's not only our thing we need to work on right now in Europe. So that's why the idea of NeoNephos came in place, to bring everything into a neutral foundation with a neutral governance model. And basically, it should give the user the possibility to pick and choose out of our fruit basket of the software components what we develop. And you can just pick and choose, but you can use all functionalities what we build. But basically, if you would want to use some legacy, or your company does use legacy software, this is also something which can be or could be combined somehow. And as I said before, it's basically a community approach. So we founded the foundation officially in April, before we had like a lot of meetings. How can we work together with companies? And we had the chance to be part of the keynote walk-on at KubeCon in London. And we had the chance to present before 12,000 developers what NeoNephos is doing. And basically, that's how we also want to work on the project. So currently, looking on where we stand, we are currently setting up everything to every guidelines and also try to involve like the community, and that's how that only works, not by a single company creating something and yeah, presenting that as a solution and everyone has to use it, but we want to work on that journey together with everyone who's interested in. All right. And basically right now, if I didn't count it wrong, we should be 14 members. And I think that's already a big step forward. When we started, we have 11 or 12 projects already, and currently also we are in the discussion of getting new projects by existing members, what you can see here, and we also have like member discussions, potential member discussions, which should join in September. So I think yeah, it will be really interesting looking at what we see in September, October with new members coming in. And start more working together on the projects which came in and will come in the next weeks and months. So basically, that's just a subset of what was brought in when we founded the solution. And Mirza will talk about the platform mesh. I don't want to go into much details because I think that's just reading out loud a lot of lines of what the functionality does. But you can also have a look on the website, neonefos.org, or the direct project page as we created for everyone a documentation around it. Okay, and yeah, so basically, where are we now? So end of August, we had the chance to participate at the Open Source Summit in Amsterdam. Gabriele Colombo from the Linux Foundation Europe, he also showed NeoNFOS on Wednesday in his keynote presentation, and really thankful that he took the chance to present it. And I think that shows the value of what is currently important for Europe. How are we dependent on others, and how can we go forward in the future to get more sovereignty and to be more autonomous? I mean, a lot of buzzwords, I know, but I think that's really the momentum on what we need to work on. Yeah, some of the developers and governing board members, also together with Mirko from the Linux Foundation, and here also Gabriele, were invited for short come together, and we took a photo. But yeah, I think it was already too late on Wednesday, so we didn't have the chance to get more people. Next time it should be much bigger, in my hope. Okay. We also just launched a new website, which is based on WordPress. Basically, everything is generated by Markdown. So we also want to invite to work together with the community by directly opening pull requests. So we really want to be transparent on what the website has to work together and yeah, to keep the information up to date as quick and open as possible. From a timeline perspective, yeah, I said that we started quite some time last year announcing the NeoNFOS Foundation at the LF member summit in Vienna by publishing the foundation in April in London. And right now, where are we right now? So basically, we are currently completing the transfer of the projects which were donated in the beginning of April. New projects are already coming in. We created the governing board. We had elections for every project's technical steering committee. And also with that, the formation of the TAC, which is deciding now on the technical contents. And one bigger step which now happens right now is that every general member has also the chance to be being nominated as a member representative and be elected in the governing board. So in our foundation contract, we have the option added that every 5 general members, there's 1 election for governing board member. So right now we should be 9 general members, meaning if 1 additional general member would join, there would be another election, and then we would have like 2 additional governing board members represented by the general members. So that's currently what we are at. We are also planning like very soon strategic meetings where we define the goals of what we also want to achieve as a foundation, as it's quite complex bringing so many companies together, working on the ideas and bringing projects in. But I think it also takes a little bit time for that. And just to highlight the next events, what we are currently working on. So I will be in Germany, Erfurt, next week to talk about foundations and NeoNephos in general. We also will have some technical presentations in Erfurt next week. It's Bitkom e.V. And it's the open source summit from Bitkom, and we will talk about foundations, NeoNephos, and the technical architecture of it. There will be also a new webinar with the Project Gardener team talking about neutral governance. You should be able to register. It's on our website from SAP hosted this time, but this is also a little bit more in a transitioning process. So basically, this will also in the future be just added also in the NeoNephos pages. Besides that, we are also in Berlin end of September by the organizers of the IPSAI founded project by the European government, talking about as well with other companies about the architecture topics from NeoNephos. And we will be with the Linux Foundation Europe again at the member summit and afterwards at the LF Roadshow event in Ghent, Belgium. So if you have the chance, let me know. We can set up a meeting and have some talks together. With that, I'm already finished with around 15 minutes or a little bit less. Thanks for your time. If you have questions, we can also do that later. And now I would hand over to Mirza.
Yes, thanks very much, Christian. I'll try to share my screen if you stop sharing.
Yep, sure.
Okay, so we should be able to see my screen now. Can you confirm, please?
Yes.
Okay, great. So thanks very much for the introduction. There's a lot of stuff that I think we'll also mention in our talk as well. I also wanted to very quickly mention that with me, I also have Bastian Echtelholter, who is our architect and help us, show us a little bit of a demo on how we want to sort of show a little bit of a vision of the platform mesh to help you understand, because we've had a lot of questions about how does the platform mesh work, what are some of the use cases can be for, and you understand that, it's a little bit of an abstract topic. So we try to give you as people as much content and possibilities and also the chance to ask questions as well at the end then. With that said, just like Christian was saying, there are a lot of projects under NeoNephos. What I also want to highlight is, of course, we'll be talking about the platform mesh per se. But the one key point I wanted to say, though, is that we do also use other projects. So we do eat our own dog food. We also use OpenMFP for the UIs, for be able then to have, you have a Kubernetes API that you then want to represent a better user experience. So we use OpenMFP for that. We also use the OCM for packaging specific components that can then be also installed. So later on we talked about managed service providers, how they can also install some of those dependencies. OCM is one way to do that. But of course, there are other projects in there that you might also be interested in to look into it as well. Now, coming now to the actual key points here in terms of the platform mesh. The platform mesh itself is trying to look at what we sort of refer to as the multi-provider cloud edge continuum. Okay, so in this continuum, there are different providers of services that are then available. You might have your infrastructure providers, you will also have your software providers. So you think about the cloud edge continuum as this overall computing architecture where you have compute on cloud and compute on the edge, and they serve different purposes. But they all offer different types of services that we then want them to consume and have them available. At the very coarse level, when we look at it, we see that there's two ways to segregate this. You have then the software providers on one side, who always want them to be flexible and mobile for your needs as an application user or application developer who depends on these services. But you also then at one side, you also have the infrastructure providers, and these infrastructure providers by design aim, for a lock-in and control. Now that's a bit of a challenge though, because the two need to play together, but they have different commercial objectives, And this ultimately leads to the lock-in problem, the vendor lock-in problem. You have these proprietary APIs where each provider speaks their own language. There's no standardization per se. Each vendor has also its own dependencies, which means that switching providers means rewriting integrations. You have this skill fragmentation where teams then need specialists for each provider ecosystem that they want to implement. And you also have this innovation barrier. So when you think about a small European providers that can't compete with the established ecosystems, but just to step back a little bit and says like, well, is this really a technology problem? When you think about it, it's mostly about standardization. So the infrastructure exists, but there is no common way to use it effectively. I will go a little bit into that. And even when you look at inside one of those providers, we see a very similar behavior.
Mirza? Okay,
yes.
now the slides changed for me, but we saw the same slide until now.
Okay, sorry. And yeah, so when you now look inside one of those specific providers, if you look at the classical definition of a stack, you'll have these artificial barriers. You'll have your infrastructure service, you have your platform as a service, you will have your software as a services, and then you have these tight dependencies between each of those artificial layers that require to have this between each other. Of course, these artificial boundaries, they are there, but they are controlled then by the provider, But then the provider itself says that, well, if you wanted to use some of those, and if you want to build some business value with these, I'm going to provide an opinionated administrative management API. You can pick and choose your words from there, but the key point is that there's an administrative domain for this vertical stack, and you need to have some way then to manage that. And of course, they're going to give them their own flavor of what they think should be. And in the background, they're patching, they're gluing things together, they're building bridges between some of those silos, between also some of those barriers that are there between, infrastructure and platform as a service, wherever it might be. But the problem is that, they try to offer their management interface for these diverse components into a cohesive platform. And this is where the APIs are meant to create the vertical integration from the business logic to the infrastructure itself. Okay. So then we come back to the challenge now with that in mind, and we says that, well, looking at the cloud edge continuum, we have these incompatible APIs across those providers. We have this increased exponential complexity when adding new providers. If you're a consumer of those providers, for every new provider that you add, you have to speak a specific domain. You need to have that opinionated management API that you need to understand. You have these proprietary interfaces that you also need to understand that as well. And then again, there is this no consistent way to consume those services across that continuum. And when you then look at it, you put yourself in that situation and says that, well, I am an application team. I'm a consumer of those services that wants to build an application, as an example, and say, I have a service from provider A, and I have a service from provider B. Now I rely on both of those, but the heavy work, the burden lies with me to do that integration. So you have this fragmentation That means that, I'm the one who has to do all of these integrations. And in the end, it comes down to you to do all of this work, whatever tools you might be using. But your problem is that you have to deal with those opinionated APIs in your own way. And then you, of course, might be wondering, is that, well, what if there was a way to make all of these providers speak the same language? And looking back at that stack, well, actually, we're not that far off from that question, because if you look more closely in this vertical stack, you will see that cloud native has already changed that landscape. And there are open source foundations that are driving that change. There are these paradigm shifts that are happening, and they are driven by these open source platforms. That's by open source in today's platforms today. So therefore, these managed service providers, as well as consumers, are already using Kubernetes. So there is no need to invent something completely new. There's no point in to bring you another thing that you have to do. You are already using it in your stack. And if you're an MSP, you're probably already using Kubernetes as is. And the key point here is that we're not talking about Kubernetes as an orchestration engine. We're talking about exposing the kube API as a control plane to be able then to use Kubernetes resource model to manage specific the concept of digital twins for services and resources that can be part of a mesh. Okay? And we do this, we're looking at providing then this harmonized way to combine it into one way to speak across all of those services, and that is using the Kubernetes resource model. So why in the Kubernetes resource model, then you will then have your KRM as your Franco Lingua, where you then have every service capability that becomes then a digital twin, where you then define a live declarative contract between what you want and what you get, thereby bridging the gap between these different cloud providers. And of course, then, where would this happen? Well, you wouldn't have this concept of control planes. So in Kubernetes, there are these control planes as well. We are here using a project called KCP. You can check it out. It's KCP.io that offers these user-facing control planes for us. Now, when you think about that, well, what's really the motivation for the platform mesh then? It's based on sort of the same principles like Kubernetes. It's supposed to be API-centric, not API-driven architecture. It's designed to be where API server manages the state, but the business logic runs outside the API server with loosely coupled controllers. You have this concept of declarative management and digital twins. Platform Mesh heavily relies on a declarative approach using the Kubernetes resource model to define the desired state of those resources. So make those controllers work for you. You also then think about choreography. The design is based on concepts of choreography. It's multiple separate resource abstractions and controllers collaborate to achieve a desired emergent behavior without necessarily a central orchestrator in the middle. And of course, you have KRM as your lingua franca. KRM serves as the common language for all declarative service management, simplifying the interactions and then enabling this cross-provider service compositions. And of course, the platform mesh recommends Opera-based installations, to update these procedures, to shift the responsibility of the lifecycle management to product-specific operators. So this also allows for automated adjustments to bring the target environment into the desired state. And the aim of this is that, we're trying to foster European digital sovereignty with this. We are being funded by public money from the EU, and we're also then trying to build a framework that can be used within EU for these types of problems that exist with the Cloud Edge Continuum. Now, coming back again to the business experience, there is still this concept of fragmentations and these lock-ins. The teams must master these multiple opinionated platform APIs, where each integration becomes a custom Snowflake solution. So you keep that in mind as you look at the continuum, and says you look into specific vendor systems. So what needs to happen? Well, this needs to be disrupted. And the way to do this is to provide then a practical standardization approach. You can then order through a common interface, that is Kubernetes resource model, the first step towards a vendor agnostic standards. No need for a standardization body involvement per se, because you already have this. Okay. So we'll quickly show a demo coming up shortly, but I wanted to do about it is that show you a bit of a diagram to help understand the demo a little bit better. In the concept of talking about orders and fulfillments and the representations of digital twins, if there is an order that comes in from the platform mesh, it would then be represented on the actual managed service provider that takes that order, creates the fulfillment on their side, and then is able then to have that workload that is then can be used and interacted with many different ways. Such an example of the HEB bin. We use that in our example. It's a very simple example that developers generally understand, and they use it for a lot of the APIs testing and the UIs as well. And the idea is that as soon as this order is fulfilled, it's available on the managed service provider, the status then is synced back to the platform mesh, where you then, the digital twins represent that representation of this exact order that you've then had. Your desired state then is then also represented in the mesh as well. Okay, well, with that said, I will then hand over to Bastian, and we can get the demo started shortly.
Sounds good. Yeah, maybe this is another slide that will outline a little bit on what you're going to see in the demo. So as Mirza said, we're going to use this example of ours that we call HED bin as a service provider. So imagine that this is representative of a managed service that you could order, and basically what will happen is that we will make this HED bin API available in a user account or user workspace, and this is sort of what this first level here indicates. And so we can create a resource of HED bin in that workspace. If you click one more time, then there's a representation or a linking of that into the provider workspace. And then basically it gets transferred to the provider side. And we will mimic this, showing like it would be an edge sort of provider by running this on my local system. And there's a KCP component called Sync Agent. And this component basically transfers the order from the platform mesh installation to the operator installation and fulfills the order. And then as a result, we will be able to see the result. This will probably be the end goal. So basically to show you how to register a new provider into platform mesh, and what this will mean for you, and to show you some more details on how this would feel. But for that, let me start sharing my screen.
I'll stop sharing mine. You can go ahead.
Okay, I hope you can see it.
We can see your screen.
Do you see the showroom?
Yes, we do.
So I'm going to demo this from a showroom. This is a remotely deployed platform mesh installation that we have here at SAP to showcase some of the features. It's in our dev environment, so you see some development related assets here. But yeah, so the first thing I'm going to do is to create an account. An account is similar to what you probably know from Hyperscaler or so, basically an entity that allows you to group your work. So we'll go ahead and do that. Call it demo. And create this account. Now, for each account in the platform mesh, you will get what we call a workspace in KCP. So it's already indicated here via this path. And I will always go back and forth between sort of the UI that basically shows what we have in platform mesh, and also this very same thing that you can see via kubectl, to always reiterate the fact that basically this is just a UI to show you what's in the Kubernetes-based or KRM-based control plane. So I will switch to that real quick. So in KCP, you can sort of switch between workspaces, and this is what this WSUse command does. So I'm switching now to this new workspace that I have just created. So a new workspace in KCP comes in with very minimal API resources. So it's the bare minimum that you get. So you have some things you may remember, recognize from Kubernetes. So things like namespaces and config maps. It also brings some, pure RBAC things like cluster roles and so on, and a few APIs we introduced from Platform Mesh. But there's not much more. So you will not see any workload related types, for example. So no deployments, no pods, and so on, because this is purely about the API exposure, not about any runtime aspects. Now, when I look in this newly created account, there's already an example provider. We have pre-registered some infrastructure provider, and I can go here and install it. And what means installing it basically means I want to use this provider and I want to enable the APIs for me. So if I go back to KCP now and run the same API resources command, there are a bunch of infrastructure related APIs now showing up that did not show up earlier, right? So now I see clusters and load balancers, and the very same thing is also happening on the UI level. So I can, in this case, the infrastructure provider resources are namespace. So these Kubernetes entities for namespacing. So again, a mechanism for grouping resources. So it does also apply here. So can create a default namespace. And if I go into the default namespace now, I see a bunch of infrastructure related resource to show, as an example here. So for example, I can create a cluster with something, and I can do the very same thing also on kubectl. So if I then say get clusters, I see the dev cluster I just created, with the input I had in the UI, right? So there's always the UI will show a representation of what you also see in the KCP-based control plane. Okay, so this shows a little bit on how you could leverage an already existing provider that is activated in your Platform Mesh installation. So now the next goal would be, how would I bring a new provider into this? And here we want to introduce this HEBin provider that we mentioned at the beginning. Now, there are a few things that a provider currently has to bring. And one thing is what is called an API export. And that is basically sort of a reference point that we would use when you install an API and you basically say, I want to bind to this API export. As you can see, there's not much in there. And we will enrich this with a link to the API definitions later on the demo. There's also a UI configuration. So in this case, we're going to introduce a micro front end for this HEBin that runs somewhere. And thirdly, there's some metadata around the provider. This is basically what you can see, in this catalog view, that we have some contact person, some descriptions around the service. Now let me prepare this. So I have a little script that loads the files, so I don't have to do this in the live demo. But basically what happens is we create a provider workspace where those resources would be, and then I just loaded the YAML files that that I showed you. So I can switch to that as well. And here you can see now, for example, the API export that I have just loaded. Now, what you will not see is another resource that's called API resource schema. And because that one is going to be filled when I start the actual provider. So basically, this is part of the provider implementation that the provider can tell the Platform Mesh, how do my APIs look like? So for that, I'm now switching basically over to the provider now. I'm basically installing the provider on my local system. So to do that, I have a little kind setup that I'm going to start. And while this is coming up, I can also explain some of the tools that we use to run this provider now locally. This won't take too much time, I hope. So let me switch. Yeah, so the first thing that's going to come up is primarily also Flux. So we use Flux for sort of GitOps-like mechanics and Helm releases within this kind cluster. You also see Nginx, because this is an application that is exposed. We use an Nginx controller here to expose the app. We also use Crow. So Crow is a technology that you can use to sort of pipeline a set of resources in form of a graph. We use this to deploy or orchestrate the deployment, if you will so. And we also use OCM, so the Open Component Model. And the Open Component Model is a spec basically that allows you to describe your applications in a tree of components. So in OCM, you can specify, this is my Helm chart, this is my image in what version, and this will help you to structure your deployments, but also to, for example, lifecycle applications into, for example, locked environments. Now I have installed the preconditions. Now I'm basically deploying the operator. So what this does is it will create the necessary OCM resources. So we should see, for example, a repository. It's a link to the OCI repository. There's a component resource. Let's say I want to deploy version 0.57 of this operator now. There's also a resource, and here you basically link to, okay, I want to use the Helm chart of that operator in this case. And this leads then to original Flux resources like the OCI repository. And when that is there, a Helm release is triggered. And with that Helm release, you then get your operator deployment, which is now here and should be running now. So with the running provider on my local client, we should now see, I didn't mention the API Sync agent. So this is the sync agent you saw on the diagram earlier, which is in charge of synchronizing the resources from Platform Mesh to this local client environment. So we should see now already the update of my provider installation. So if I look at the API resource schemas now I see one. And this API resource schema is basically what you may know from custom resource definition. So it basically contains the Open API specification of the API of that provider. And now this is known to KCP, and I can then use it in Platform Mesh. Okay, so going back to my browser, now I see the second provider that is registered now, and I can use it. So installing this as well. So going back to my namespace, next to the infrastructure UIs, I now see the HG bin UIs. So I can create a new bin. It's called dev. And as before, if I switch now back to the user workspace, I will see the HG bin resource. HG bin, the one I just created. And it are, you see, for example, the enable HGS that I provided, but you can already see a status update. So this was nothing that I provided. This is already feedback from the provider. The very same thing you will see here on my local client now. So also this client has the very same resource. So I can look at HG bins. And this is the bin that was just synchronized, from the remote Platform Mesh to my provider. And the provider acts now on this order and creates, for example, a deployment. So there's now, a very new deployment that actually deploys this service that was ordered. The provider now will at some point then update this resource to indicate, okay, this is ready, this can be used. So yeah, now it happened. So basically now my bin is ready. The very same thing, of course, will be updated also here. So you see the ready is here as well. And this also means on the UI level, the progressing button is gone. And now I can open the application, which is also running locally. And this sort of shows the end-to-end sort of fulfillment of a resource that was requested via the Platform Mesh. Maybe to reiterate a little bit on what we've shown. So basically we introduced the concept of accounts and how you would enable a certain provider, how these provider APIs are visible in the respective community space control plane, and then how the fulfillment process would look like towards a provider. Yeah, I think this is all that I had to show for the demo for today. Maybe one thing to maybe reiterate or state is, as we build fully on the Kubernetes resource model, of course, the whole CNCF ecosystem of tools is at your hands, right? So we're fully compatible with Kubernetes in that regard. So you can use, tools you may already be using to also orchestrate resources within Platform Mesh naturally. Okay. Then I think back to you, Christian. Yeah,
thank you very much for the presentation. And I also want to say we don't want to reinvent the wheel and create these components over and over again. So we are not in a competition with the CNCF, but we want to focus with the NeoNetFOSS Foundation on our area and to reuse as much as possible. So that's for that. And with that, I would open the room for questions. How did you like the presentation? Do you have questions to it? And in general to NeoNetFOSS, how do you want to interact with us? Do you have ideas, questions? But yeah, I leave the room open now for your feedback. Thanks. Okay, I see a lot of thumbs up and clapping in the hands. Anyone wants to share some audible feedback to the round?
I also just want to say is that, we did a presentation this morning also at Container Day. So some of you might have already seen it there. So if you've seen this before, apologies, but there was a lot of interest to reiterate this again and maybe demonstrate a little bit of a better demo with help from Bastian to explain it a little bit better. And also the things that technologies that Bastian is also showing. We mentioned Crow, we've also mentioned OCM, you can also use, instead of Crow, you can also use other tools. It's just a theoretical representation of what might be happening on the managed service provider side. There's also a question that came up this morning as well. We had demonstrated in demo with Crossplane, but doesn't mean that we use Crossplane. It's just one way. If there's anything that speaks Cube, we can use it. That's the idea.
So this being a cloud age technology, specifically meant for cloud, of course, do we have something that it's a little bit approaching the same concepts that we have already in other clouds? I mean, it seems to me that KCP is quite a unique approach. I didn't find anything like it in my experience until now. And what would be beneficial for me, it would be to know better exactly or towards which direction are we trying to steer with this technology. Of course, I do see a lot of possible uses, but it seems to me that they are not quite in the same philosophy and the same direction that general big clouds are going with.
Yeah,
so do we have
go ahead.
direction to go to?
Yeah, I mean, so from our side, at least, what I want to say is, so we're still starting, so we are trying to develop something that can be used with the goal of, making it enrichment for the Cloud Edge Continuum as well. One of the questions that also we had this morning was that, will you be able to then order resources from hyperscalers? Well, you can. If you have providers from those, then you can do that as well. There's also, other concepts that we can also are talking with the other participants inside the IPSYS work streams themselves to try to understand the concepts of federations and then how to bring that also into the mesh itself. But there is no specific way right now that I would say is for the platform mesh to say it has to do one particular thing. Maybe if I redefine your questions a little bit better, maybe I can understand it.
No, it's not about a specific thing, of course, because you cannot have a specific thing because you can do lots of things, and it's about putting pieces together. So one thing that passed through my mind is the possibility of using hybrid. I mean, what we have already with some hybrid clouds and stuff like that, but only using Kubernetes. That's also something that came to my mind as a possible usage. And yeah, I do see its usage a lot. So it's possibilities for using it.
So in general,
Absolutely. Go ahead, Bastian.
yeah, I think it's quite complementary to things that are out there. I mean, certainly from a motivation point of view, there's obviously a difference between the motivation of the hyperscalers and what we are trying to do here. And I think we are trying to create a foundational technology that is especially helpful in Europe, where I think we have seen a lot smaller companies rather than big hyperscalers. And I think this could be enabling technologies to bring services from many smaller companies potentially together. But also it has quite a wide applicability, so it's not focused on infrastructure, right? I think for infrastructure, there are also other technologies like Crossplane that already achieve sort of a joining of things on a KRM level. And I think we're complementary to that. So of course you can consume also Crossplane resources via platform mesh, but it has a wider applicability than the infrastructure realm, I think.
Yeah. Okay. That's much clearer. Thanks.
I actually have a question. If I understood properly, we assume that all providers will use the same CRD for like same type of resources. Like for example, EC2 instance on AWS or whatever it's called on Google Cloud. And my question is, how is it possible to create such a good CRD that will cover all options on different providers, and how they agree on it?
So yes, that question also was raised before, but it's a little bit of a misconception actually, is that there is not one CRD that represents the different types or different categories that are offered from different service providers. So for example, we take virtual machine here. One provider defines it in one way, another provider defines it another way. But what you do have is that you do have this control planes with KCP, where you can then build, when you use platform mesh, you can then find a way and build on top of it and says that, okay, if I want now to offer different virtual machines coming from different providers, you can then use virtual workspaces to group those together and give this ability for the consumers. And we are looking into that on how to make those transitions with similar groupings as seamless as possible from one service to another service. It's not going to be perfect. It's not going to be fully automated. But there are ways then to do this by saying that if we can define some sort of generic API interface in KCP, that then when you come in as a provider of a specific category, you implement that API, then we can expose it in a more generic way that then allows them for consumers to switch from one provider to another provider later on.
And maybe to add to that, in general, I think, a platform mesh, I think is a first step into that direction, right? So basically saying, okay, if we are successful and manage to get a standard around KRM, then additional standards can evolve, right? So once every provider speaks KRM, it will be rather easier, but a follow-on step that could happen then to align on details of the manifest. But at least we are already speaking the same API. And I think we saw this for things like cluster API or so other things have evolved already once providers were speaking the same language.
And speaking from the view of the architecture task force of IPSASYS, that we are currently coming from the other direction. We are looking into how can we describe resources in a comparable way, right? So if two providers would provide virtual machines, how can we describe them in a way that you can compare them? So there's still then a gap between discovering things and ordering things, but we're coming basically from the other direction. At some point we will hopefully meet, and then this will build a complete picture.
Okay, thanks. Can I ask a question? Yeah. So my next question is, when you created HTTP bin, I saw that it gives you URL in status. So basically, you have some feedback information in your KCP. And do we have like plan or ideas how can I like sync it with my external Kubernetes cluster, or maybe with external software.
Yeah. So this example goes primarily to the concept of what KCP has on its workspaces, and then this API sync agent that runs on the managed service provider side syncs from the workspace the spec to the service provider, and then returns then the status to the workspace. So there's no workload running in the actual account per se. But what you're referring to is also another project that we're working with, not just KCP, we're also working with multi-cluster runtime that also came out of KCP. We're of course working with the sync agent. We're also working with another project called Qbind. And Qbind would allow this that says that if I order a service in the platform mesh, I have this service entity, this digital twin representation in the mesh, but I have my own workload cluster that resides somewhere else. How do I bring the service now into that workload cluster? And that's what Qbind would do. It would have some sort of connector that brings in that API into that workload cluster as if it were part of that cluster. However, that's still a lot of work that we're working towards to make that possible. But that is also part of the vision for Platform Mesh as well.
Okay. So I have another question. Basically, we have providers, we have consumers, well, the API binding, everything else. So if we have, for example, one KCP cluster, one KCP control plane, which it's connected to several clusters, it has some consumers defined for several providers or some stuff like that. Can I have another KCP cluster that connects to the same consumers or to the same providers in the same cluster or not? I mean, are they? And if yes, if I can have, for example, two KCP control planes, each one of them connecting to the same provider, I have a way to separate their source. I mean, it's stateful, it's stateless. That what we have in the backend, it's how it is conceived.
But yeah, we see exactly that. I mean, that's the model that we aim for, right? And of course, as a provider, that you would be able to connect to various platform meshes, and then manage, the respective orders. Of course, there are some very, options on how you would build the provider. But yeah, that's exactly the model that we aim for.
Okay, and the statefulness or the stateless of the provider itself. So, for example, if I have one KCP that connects to my provider, I have two KCPs that connect to my provider, and one of them is going to provide data for one client and the other one for another client. That's left to the provider to do the separation, or is that a possibility, for example, to connect to the provider with certain parameters to basically say, okay, just serve me for this and
Yeah.
do the separation at level.
Yeah, there are certain variations in the implementation that you can do. I mean, on the one hand, there are a number of configuration options on how you would configure the sync. Typically, you would have namespace level separation if the provider just uses a normal Kubernetes cluster. The provider, of course, could also use KCP. Then you would have a stronger separation between those, connected platform meshes. So there are some, variation options depending on the provider choices. Yeah.
Mm-hmm.
And you can also have more control. So the sync agent is just one way to make that connection between KCP and the provider side. You could write your multi-cluster control using multi-cluster runtime to have an operator which has, more fine-grained control if you wanted to have that as well.
Mm-hmm. Okay, and also, so I think I saw something, but I'm not 100% sure. Do we have in KCP already validating admission policies and mutable admission policies and stuff like that, just to improve the security on what we have to do?
On the top of my head, I'm not sure. Maybe Bastian, if you know.
Yeah, I mean, KCP behaves very similar to a normal Kubernetes. So things like webhooks or also cell-based webhooks and so on. These things are possible.
Okay. Thanks.
Yeah.
Okay.
I have a question.
I just want to say we come to the end, and I would give the chance for one final question. So, who was that, Marek?
Yeah, that was Marek.
Yeah,
First
okay.
of all, thank you for the presentation. It was really nice. I have a question. There was an example with the HTTP bean, and the resource schema, it was provided by the provider, so it was available only when the provider was connected. And I'm just wondering if that's actually not something that should change in the future, because if every single provider will provide their own schema, then you cannot simply switch from one provider to another. So the concept of provider actually in this case doesn't work. Shouldn't that be that there is a spec provided by some, I don't know, maybe Cloud Native Compute Foundation or whatever, and then there are providers that implement the spec? Is anything like that, or the movement in that direction is currently on the radar?
Yeah,
That's actually an interesting point, because we have the project Catalyst in NeoNephos, and there we have multiple telecom providers all over Europe coming together to actually define telecom APIs based on the Kubernetes resource model, which would be then 100% compatible with Platform Mesh. So that's things that we can't do, right? So there are a lot of different industries. We cannot define things for all the industries. But the hope is that once we have this Kubernetes resource model idea established, that standardization bodies will jump on it. And with Catalyst, we see the first movement in the telecom industry.
But still,
Thank you.
Even if there's no standardization of the manifest, I believe that if you look at how would you change providers in a standardized manifest, then likely in your manifest you would change maybe provider name to be something else, one field in the YAML. Now you would have to change several fields in the YAML, but you're still using the same API. So it's a lot simpler to switch between kinds than it is to switch between APIs that are completely behaving differently, right? So I think there's still quite a value gain by aligning on KRM even without a standardized manifest. But of course, it can always be easier. But I think we do a very valuable first step here. Yeah.
But if I have one standard, then I can create resources and, for example, say that in this workspace I want to use only that provider, right? And that can be configured on the level up.
Mm-hmm. Yeah,
if the resources are different, then I cannot do it, right? And I can switch to different provider without even notifying the let's say child workspaces, right? I can switch on the higher level.
If that's somehow related to the question that I have with validating admission policies, if you have those integrated with workspaces already, then you can just say, okay, you are not allowed to do this, to use this provider in this workspace, and that's that.
Yeah. And I'm not disagreeing with you. I'm just saying, we're doing a valuable first step, and other technologies are still there and can be used. So, for example, crossplane with compositions, would also allow you to abstract, manifest differences, for example. But yeah, if there's a standardization that evolves, then it's even better, for sure.
Okay, thank you for your answer, and once more time, thank you for the presentation.
Thank you for attending.
Yeah, thanks. So we are already over time. Thank you for joining this community call. If you want to reach out to us, if you have ideas on what should we present, if you have questions we should answer, we are available on our website. We have the mailing lists. You can just reach out and send us a mail. And yeah, with that, we're happy to host the next community call. See you soon, and maybe see you on the next conferences. So take care. Bye.
Thank you. Bye.